Hello, today we will solve the two-sum question at Leet code. In this question, basically we are given an array and we need to find two numbers which would add up to some target number. So in this example, as you can see, we are given an array 2, 7, 11 and 15 and our target is 9. So by looking at I, we can see 2 and 7 are our candidates would add up to 9. And because of this, our output is 0 and 1, which are the indices of 2 and 7. Now, in this question, which is nice that we are given that we have exactly one solution. So we don't have to worry about the solutionless case or we have more than one solution because it is given that we have exactly one solution. So let's investigate it further. So we are given an array and let's say we have some numbers in it. Also, we have a target number, which is 9 in example. So in order to do this programmatically, the most trivial way to be iterate over this array twice. What I mean that is, we can iterate over it once and take 2 at the first example. And after the second iteration, we can get 2, 7, 5 and 11. We can ignore 2 here because it's at the same in this. And sum these numbers to get 9, 7 and 30. And after that, we obviously in this example we have found our target, but that might not be the case all the time. We would iterate by fixing 7 and add 2, 5 and 11 to it, and we'll get 9, 12 and 18. So over these iterations, we would make n times n computations because we would fix one of these numbers and iterate over the n elements, and after that we would fix other number and iterate over it. And so in the complete solution, we would fix n times and we would iterate n times for every fixing we made. So obviously we would make n times n computations. Actually, this is the brute force approach to this solution. And this brute force solution would require O(n) squared time complexity, but we wouldn't be holding any other data structure or storage, so it's actually O(1) time complexity. And sorry, yeah, this now looks better. So let us try to implement this strategy in Leet code. So basically we are given an array and we would iterate over that array. I would just enumerate it because I would also be needing the indices. So while iterating, I should make a second loop because I would check if those numbers add up to our target. Now I actually need to make a control because if I equals j, that means I am adding up the same numbers, which is not wanted in our case. So at that case, if m plus n adds up to our target, that means that we have find the solution, and our solution would be the e and j indexes. So let us submit this and wait some time. So we have submitted it in, and you can see we got a success. But as I said, this is actually a brute force solution, and O(n) square is not very acceptable in this question. So let us try something else to solve this question in a more efficient manner. So actually, what can we do is we can just iterate over this array just once. We can just get 2, 7, 5, and 11. And for the sake of the argument, I would actually change the order of these numbers because this solution would, we would get solution too quickly because 2 and 7 are at the beginning. So let's say that we have 5, 7, 11, and 2. So in this new array, what we want to do is we just want to iterate once, and after that we need to find a solution. To do that, we will use another data structure. If you want, you can pause this video now and think about it, or try to code it, and what might this solution would be. And after that, you can come back and watch the solution. So, if you have solved it, great. But if you haven't, don't worry. These questions could be seem a little bit hard at the beginning. So what we will do is actually we would use a hashmap, which are actually dictionaries in Python. So while iterating over this array, when I see a 5, I would just put it in my hashmap, and I will put it in this as its value. So after that, when I came to 7, I would do something like that. If 9 minus 7, which is 2, is in my dictionary, that means that I have found a solution. And looking at a dictionary for an item is actually an O1, requires O1 time complexity, so I'm absolutely fine here. But if it's not in the 2 is not in this dictionary, I would just add 7 as in this one. So same way, when I look at 11, I would just look, is minus 2 in my dictionary? So minus 2 is not in my dictionary. So I'll just add 11 to my dictionary as in this 2. So finally, when I reach to 2, I would look if 7 is in the dictionary. 7 is in dictionary, so I would say that my solution would be 7's in this dictionary and 2's in this, which I'm just iterating over now. So let's try to put this idea into code. So I'll just delete these, and I said that I would need a hash map, which is actually a dictionary in Python. So I would just iterate over the nums array just once, and I'll fix the little typo here. So while iterating, what I was doing is I just add my number to my dictionary, which is key is my number and value is my index. So, but before doing that, I need to check that if target minus n is in B. Actually, no need for is here. If target minus n, target minus my number is in my dictionary, that means that I have actually found my solution. My first index of my solution would be my dictionary's target minus n value, and the second one would be I. And if target is not in my dictionary, if target minus n is not in my dictionary, what I would do is I would just add n as the ith n key and I value to my dictionary. So let's submit this. Oh, it seems like I have forgotten a syntax here, and I'll just submit it again. Also another syntax error. This is a function, so I never get these right at the first time. And as you can see that our solution is now successful. The important thing to note here is that these runtime values could be surprising time to time, because it's changed with the dataset they gave in the solution to this function. But you can be sure that over very large nums, this solution would require much less time than our first brute force solution. But for smaller array sizes, this can change because we are initializing a new dictionary here, and those things takes time. So for smaller numbers, for array sizes, this could run slower, but for the large arrays, this would be more efficient.